So this is almost the final session in this room for today. And now on the agenda, we have CQRS Pattern implementation with CAP. And I had to Google, what does that stand for? And it stands for Command Query Responsibility Segregation. So Alper will show us a powerful combination of CAP, AWS DynamoDB, and SAP HANA Cloud to implement such a pattern. And Alper will also show us how CAP seamlessly integrates with AWS DynamoDB for efficient command and query handling while using the HANA Cloud.
So, excellent. Thank you very much for all the research. So that's really kind. Welcome everyone. Today we are going to talk about the CQRS implementation with AWS DynamoDB and SAP HANA, of course, and using the CAP as a programming framework. I will explain briefly what CQRS is, then I will go into how I implemented it in this case, and then I will show you a demo about what is the benefit of implementing this architecture. Of course, it has more complexity, but what is the gain at the end after having this complexity? So who am I? For the ones who don't know me, I'm working in SAP Platform Adoption and Architecture team is the new name, but just forgot to update the name. For the Platform Architecture and Adoption is the new name. So basically, we work for BTP and everything around BTP. Also, we work together with hyperscalers to create reference use cases, architectures for our customers, partners, even sometimes for internal colleagues. So I will start now after this short introduction. What is CQRS? So CQRS is basically a design pattern that you have different data models for commands and queries. So why would you need that? So basically, imagine you have a write-intensive or read-intensive application, and you have only one database. Imagine you have all the load of your application in the same database. Then, if you have so much writes, then your read queries would be affected. Or if you have so much reads, your write queries would be affected, because you cannot separate those things that easily from also in the application layer and also model layer. But in CQRS pattern, so commands are responsible of making changes in the data, create, update, delete. And query means read data. And we have already very well separated in CAP. So all of these things are very well at the moment already separated by CAP. I will just show how do we separate the DB connections, and it should be, pretty straightforward implementation. So why would you use this? So of course, first thing is performance. So imagine you get 1,000 or 2,000 or millions of requests. So how millions of write requests, millions of create requests, you can handle them into a write optimized database, like NoSQL database, in this case, DynamoDB we will use. And then you can replicate this data to HANA, which is excellent for analytic queries. So this is basically, you get the benefit from the so to say, write intensive DynamoDB, and also you can use the SAP HANA Cloud for powerful analytic queries. So that's the idea. And you can also later separate your reading and writing applications, so that reader and writer applications, queries go same application, and then commands go to different application. Then you have independent scalability. So let's say you have 1 million write requests, you can scale up. Pros, as I said already, most of them scalability, flexibility, optimized models for command and query differently. In this case, I will use same CAP model, but you can even change the models. And command specific logic you can have, of course. And also performance is a bit improved in terms of writing. I will do the demo for write intensive today. Cons, it's complexity. It's more complex than normal application development, of course. And consistency challenges, because at the end, it will not be directly on the HANA, it will be eventually consistent. So we will trust that some point of time, it will also appear in HANA database. Hopefully, I will be able to show you in my demo, if everything goes fine. So how the demo looks like currently. So this is the interesting part. We have a CAP application for commands. Let's say we send the create orders, create products request to our CAP application, and then CAP application first writes to DynamoDB. Second, DynamoDB sends it to a pipe. It's in this case event-bridge pipe because it was easiest to integrate. And then it goes to a queue, FIFO queue, basically simple queue service. And then it sends to the CAP application back. And then CAP application writes it to the HANA Cloud again. So basically, we had write intensive, all the write data to the, we are bombing the DynamoDB with writes, then slowly, eventually writing other data to the HANA database. So we will see that HANA is not, we will see that it's replicated HANA in some point of time for our reporting. So which use case, for example, let's imagine you have a Black Friday. You have a lot of orders, you have thousands of orders, but you don't, you have also reporting layer. And you would like to see the reports, but it's not necessary to be super consistent. You can just see two seconds later, 3 seconds later, your reports, and this should be all fine. So this is, for instance, a good use case for CQRS pattern. I can switch to the demo now. So let me show you briefly first the implementation. So we have product. I will use products entity, orders and products, but I will use products entity in this demo because it works. I know it works. So, and I have an action in this application since I'm using the same application to sync incoming data from AWS to CAP application to the HANA DB. I will show you how the implementation looks like. So here, when we send to our entities, any entity in this application, which is stated by star, create, update, or delete requests, it will go ahead and then basically put the data to the DynamoDB. Then, as we see on the presentation, DynamoDB will put the queue, and then queue will send back to the CAP application, then we'll write to HANA. So this is the entire flow end to end. And on the sync from queue to CAP application, we have this sync action. This sync action basically is a very simple and primitive one, basically. It's just creating a transaction, and from CAP, this is already automatically committed. Hopefully, otherwise this won't work. Then db run query command is basically the CAP command. So we save the rec.query to the database, DynamoDB. On the other end, we get the very same query and then write it to the HANA database. So this is basically separated completely. So, okay. Anything else could be interesting? No, I don't think so. In this case, here in the application layer. Maybe I can do more a bit and open the load test. So I created a load test with some tool called Artillery, which is not important in this case. I will just briefly explain how I do. First, we will send one request in 1 second. And to this endpoint, as you see here, products, and with some token at the end, it will be replicated also the HANA database. So that's at least what we hope. And let's do this. So first, of course, let's refresh the token because I'm talking for some time. Okay. Somehow not automatically refreshed. Let's go to here. And then paste the token here. So, okay, then the next step is basically we need to open this in terminal. And then let's first send the request to DynamoDB. I will show the record in the DynamoDB and later the record in the HANA, hopefully. So let's see. Artillery run generate load test YAML. So what we will do, it will send the request 1 second. Currently, I will start only with one request. So let's send it back to the Artillery. And then Artillery will run the test suite for us. Okay, so we sent one request, and basically it was successfully processed. It's sent to the DynamoDB. Let's check if it's really the case. I need to escape from and then go to here. So let's go to DynamoDB. We have some tables. This is the order commands table, which is created by me. And let's explore the table items. We have, in this case, 3. So, and as you see here, command is an object, which is basically representing the CQN of the incoming query. So I saved also the command as an additional property in the DynamoDB. This is fine. Then let's go to HANA. Now this is connect to database explorer. Okay. Fresh. So we have 3 records in DynamoDB, 3 records in HANA. Let's increase our load a bit. Let's do 100. So we change duration 1, arrival rate is 100 per second. Let's send this. I have only 1 instance, by the way. 1 cup instance running on the CF. So not cheating or something. So, okay. Response time minimum 22 milliseconds, maximum 100 milliseconds, which is okay. So let's see if it's increasing. Okay, 57 is already there, 64 is already there, 76 already there, 91 already there, 103. Okay, we are done. Data is completely replicated. Let's do a bit more. 100 is. Let's do a bit more. Let's do a bit more. Let's do 1,000 in this case. 1 million also should be possible, but you need to provision more DynamoDB write capacity. That should be possible. So let's send this. Let's see this time how is the latency. Then we understand our application's edges. Okay, so minimum was 27 seconds. Maximum was 3 seconds in total, which is not too bad, could be improved. Let's go to the HANA side and see if there are really new data coming. Okay, 370. As you see, it is updating, and the good part is this is a FIFO queue. So if you need even more throughput, then you can use other services like Kafka, Advanced Event Mesh, or Kinesis from AWS. A lot of options are there. But the point I would like to make here is you can use also, if you have these scenarios, these kind of scenarios, the CAP is really making your life easy. Yeah, please check this implementation here. This is, I mean, how many? This is 48 lines of code in the implementation layer. Because what is the most crucial part? I made use of CQN. I made use of abstracted query notation, command notation. So every command in CAP is converted to something that we could use across applications, and this is helping a lot in this case. This is the point, actually, the most crucial point. In this case, this is DynamoDB. In future, you can do any other database, and also that's why everyone can develop DB adapters for CAP and open source, publish it as an open source module. So this is more or less the idea. So I have 1 minute, I guess. Okay, yeah, then we can, yeah, I'm finished now. So it is already. Okay, then questions, including questions. Yeah, then questions, please. If you have any, of course, yeah, please. Or Dana? Yeah.
They want to clap first. Go clap. It was a great session. So where was the question?
Okay, it's already happening.
Hi, thank you for insights. Could you please repeat how after you write to DynamoDB, and then
I sent the date basically. Let me show you
how it gets back and how it identifies that it should write that it's a lambda function which tells
there is no lambda in this case. There is no lambda. So
yeah.
Let me go to the event bridge pipe. In this case, yeah, this is technology specific, but in this case, I will explain this AWS case, what I did. So I have two pipes, DynamoDB to SQS, and SQS to something called CAP, API destination. You can define also API destinations like in BTP. I did XSUA definitions or two credentials and so on. Then I was able to call CAP from an SQS queue. That's how I did it. Yeah, that's the new service from AWS to replace Lambda necessity between the DynamoDBs. Exactly. Right data. Exactly.
Thank you. I was curious with this scenario, how you'd envisage the UI might work.
Yeah, since you have everything in HANA, since you have everything in CAP models, you can completely use all of your elements, for example. You can develop still applications with annotations. You can create analytical queries. You can do analytics annotations and show fancy charts on top of this data. Okay. It should work.
But you'd need the UI to sort of be asynchronous. The changes that you make, you have to wait for.
Yes, the command, it's since UI sends a query, it goes to HANA database. So you will see the data once it is replicated to HANA database in UI. Okay. Yes. Thanks.
Any other questions? There's one.
Oh, here,
okay. So you have delegated the query via event handler, and the event handler
commands going to the DynamoDB, then event bridge. Query is going to the HANA because HANA is what's good at. HANA is really good at analytical purposes.
Queries go to HANA, but the inserts go to the event.
DynamoDB, yes. DynamoDB, then event bridge. First DynamoDB. So here I can show you. For example, I create a pipe. I say source here. For example, I can choose a source, DynamoDB, and then I choose my table that I created for order commands as a source. Then I say my target is SQS queue. Send, when I send any request, update to the DynamoDB, send this to the queue. So this is automatically integrated here.
So I could also do this with Microsoft SQL Server.
You can do it. Probably the configurations might differ, but the concept is the same. You can do it.
And the costs for the event handler from Amazon is
pennies, I think. I don't know much, but
not so much.
I think shouldn't be too expensive to have pipe. Unless you have millions of requests passing by every single second.
Okay, thank you.
Thank you. It might be subject to personal opinion, but how much of that is an interesting scenario? Let's do it. Let's use another database in the cloud with CAP. How much of that is CAP must have this kind of feature to stay relevant in the long run? Or customers are facing such kind of issues and
implemented this on production? That's the question.
Yeah, because
yes, I had
in the end
on my former job, and we had, for example, a lot of requests, 100 megabytes of requests that we need to handle. So sometimes ABAP stack or the traditional databases, it's not technology dependent, cannot handle that much. They are not designed for that. So in that cases, this is useful.
Yeah, but don't you think I'm playing the devil advocate here? This might go against leveraging HANA Cloud in favor of other databases?
Computing even with HANA Cloud, because this is a NoSQL data. So you cannot do queries. You cannot do analytical performance things with this database. This is just optimized for write-intensive things. And it is not competing with HANA. It is just complementing in this case.
Great. Thank you.
Wait, the microphone is coming.
Thank you. So now for the adapter part, you already had like an API from Amazon for doing the queries to Amazon.
For writes.
Yeah, for
creates a-
doing the writes.
yes.
There is an API, there is an SDK which you can use. But imagine there is you want to use another database which doesn't have any SDK or API. How easy is it to make your own adapter in the CAP framework?
Okay, the plugin session actually Ram had.
Yeah,
really
I
excellent-
know how to write the plugins, but specific to this
Okay,
type of.
I think should be relatively straightforward, because the thing is we have everything defined in season and we know the model details. We just need to convert that information to DynamoDB table. Should be relatively super straightforward, for me at least. That's my opinion. But of course, a lot of hyperscalers also, we as big software company, we also have this SDK, so should be fine if you don't develop your own database. But you're right, converting to a CAP service should be relatively straightforward, in my opinion.
So thank you, Alper. I think that was a very interesting use case and exciting session.